he come to stage two. He's the API architecture and standards talks. So we are happy to have Tim, head of developer experience at Atlassian. He will be talking about why API aren't enough, why SaaS leaders are investing in iPaaS. Thanks, Tim.
Hello, API Days Hong Kong. I'm Tim Pettersen, or Cannon Boy, on various forms of social media, and I head up the developer experience team at Atlassian. My topic today is when APIs aren't enough, why software as a service leaders are investing in integration platform as a service. First up, a little bit about me. I've been at Atlassian for 17 years in a variety of roles across engineering and developer relations. That little picture there is a bobblehead that they gave me at 10 years, which is now looking like a much younger, less grey-haired version of me. I've spent about the last decade working in various capacities across Atlassian's ecosystem platforms. Previously, I was a platform engineer and have contributed to 3 generations of Atlassian's APIs across our server and cloud products. During my most recent stint in engineering, I led the development of our new hosted API platform, Atlassian Forge. But before Forge, I led our strategic integrations team, building apps on the Atlassian platform that consumed APIs from a range of strategic partners, including other SaaS leaders like Google, Salesforce, Microsoft, and Slack. I like to think that playing my platform engineering role as an API producer and my app developer role as an API consumer at different times of my career has even given me a broad perspective on API design. Now, I'm not really sure if that's true, but it's certainly given me some strong opinions and made me regret some questionable design choices that I made in earlier versions of our platform. Now, when I'm not writing software, I also enjoy speaking and meeting like-minded technical folks in the community, though this is my very first API Days and my first conference since the COVID-19 pandemic, so I'm very excited and honored to be here. I'm also a little sick as I record this, so apologies if the audio is not great. I promise I don't usually sound this nasally. If you would like a better recording or have any questions, please reach out to me on social media and I would love to chat. So, you may have heard of Atlassian, or you may have used one of our many products, including Bamboo, Bitbucket, Crucible, Fisheye, SourceTree, or one of our many flavors of Jira. Or you may not. Doesn't really matter for the purposes of this talk. But even if you have, you may not be aware that on top of these products, there are a set of platform services, extension points, and APIs. And on top of those APIs, there are tens of thousands of tools, integrations, and miniature products that have been built by our fabulous developer ecosystem. Now, our ecosystem and the people in it are super important to Atlassian for 3 big reasons. The first is that strategic partnerships are crucial to our product strategy. Jira has an open toolchain approach, and over the last few years, we've launched strategic integrations with a number of different Git service providers, DevOps partners, and security firms, all who've built on top of our APIs. In some cases, we've also acquired partners who we've built strong integrations with, and their products have become a core part of our product family. A lot of our corporate development is in part powered by our API platforms. We also have a large commercial marketplace with hundreds of independent commercial partners selling apps to our customers. This is an important revenue stream for Atlassian because we take a licensing fee off the top of these sales, and we just passed $3 billion in lifetime sales in Q3, purely off the back of our API platforms and the hard work of our ecosystem. And finally, we have a ton of Atlassian end users across our products using our APIs to improve their own workflows and productivity, or to integrate our products with their own internal systems. And we see a strong correlation between customers who build their own apps and long-term customer retention. So we also believe that this helps us maintain core product revenue by having stickier products. However, while our ecosystem is pretty awesome, we realized a few years ago that it was not as successful as it could be, particularly in cloud. We came to this recognition because we're in a bit of an interesting period in Atlassian's history. Today, in August 2023, we have 3 supported deployment models for our software. We have our cloud offerings, our server offering, and our enterprise data center offering. But on February 15th next year, we're officially ending support for Jira Server. And all of our remaining server customers will need to make the choice of migrating to our cloud offering, which is a SaaS service operated by Atlassian, or migrating to our data center products if they want to continue self-hosting. Now, for most customers, we're strongly recommending they migrate to the cloud for all of the reasons that SaaS tends to be a better model for everybody. However, we noticed that apps play an interesting role in the decision process that customers make and their migration journey. And there were three key things that we've seen. The first is that some customers were dropping certain apps during their migration to cloud. We also noticed that some customers were electing to shift to data center instead of cloud because they wanted to keep using particular apps that didn't meet their needs in cloud. And finally, some of our server app developers weren't rebuilding their apps in cloud even when there was significant customer demand for it. We noticed this in particular with smaller marketplace partners and also in-house developers. Now, our hypothesis is that customer and developer behavior is driven by large differences in how our APIs work in our cloud and data center products. So we started on a journey to overcome those differences and hopefully give our cloud ecosystem a huge boost by making it more appealing to developers to build apps for our cloud products and simultaneously make the apps that they were building more appealing to our customers. Now, in the next section, I'm going to get into a bit of detail about how our cloud and server platforms differ. And to do so, we're going to go on a little historical journey into why Atlassian has an API in the first place. In 2002, Jira was born. Back then, there was no cloud, there was no server, there was only Jira. Atlassian was a young company, but Jira grew popular very quickly, even with a relatively limited feature set, and feature requests came pouring in from our early adopters. Atlassian co-founders Mike Cannon-Brooks and Scott Farquhar decided to institute a permissive source license for Jira. That meant that customers were free to modify the source code, recompile it, and redeploy it to extend the functionality of Jira to meet their own needs. Now, this had the desired result. Users could customize their Jira site to do whatever they wanted, and they built weird and wonderful things. But this wasn't really an API. Customers were just hacking Jira's source, which had the side effect of sometimes making Jira unstable, or could make upgrading really difficult. And so we introduced a plugin system. The most recent version of our server plugin system is based on Java, XML, and OSGI, which is a Java standard for modular development that's now almost a quarter of a century old, but was pretty cutting edge when we introduced it in 2008. This plugin system revolutionized our ecosystem, as each plugin was now an isolated package, and we had formal API boundaries between Jira and plugins, which made them much more stable and allowed us to upgrade products and apps much more smoothly. Now, over time, Jira matured, and we built out REST APIs to allow our partners to build more slick user experiences. We built out platform components and utilities that solved common problems relating to plugin development, and we added a storage layer for apps to store data. We also improved our APIs and tools to the point where you could often build a simple app in a day because it was just a few lines of Java code. Authentication, authorization, storage with automatic backups, internationalization, styled UI components, everything except the core business logic for your app was provided by the platform. And a simple dynamic emerged. We kept investing in the platform, and our ecosystem kept getting faster and faster, and would keep building awesome stuff to delight our users. And for the most part, this has been a simple, powerful model that has stood the test of time. Apps built by our customers and by our ecosystem are deployed on tens of thousands of Atlassian products all over the world. However, things were a bit different in cloud. Like most SaaS providers, Atlassian's first cloud API platform was built on various client-server technologies used to communicate over the web, namely REST APIs and webhooks. UI extensibility was also a big part of our server ecosystem, so we built a fairly convoluted iframe-based system to allow app developers to extend the UI of our cloud products. We called this platform Atlassian Connect, and 1.0 of that platform launched in 2014. And look, this has let our ecosystem build a huge range of apps in cloud over the last decade. But it was not an easy journey for many developers. In our server products, building an app can be as simple as a few lines of Java. But in cloud, even the simplest app, a developer has to build and operate a full-blown web application. There was a learning curve around scale and performance as well. In server, apps are installed in a single customer instance. In cloud, your app is a web service hosted under a single domain, which has to be able to scale to serve all of your customers simultaneously. Now, this is not unique to Atlassian, by the way. If you're building an app for a SaaS ecosystem, you're usually building a freestanding web service that deals in webhooks and REST APIs. Over the years, we've created a bunch of SDKs, libraries, and APIs to platformize and simplify as many aspects of cloud development as we can, but none of them really come close to the level of platform power that we had on server. Some developers have suggested that the effort or costs involved in porting apps to cloud are too high and simply aren't planning to migrate. One particularly poorly impacted segment is in-house developers. We see far less in-house development in cloud than we did on server. And that's how we knew. While our cloud ecosystem is wildly successful and lucrative, we could also observe that we were leaving some developers behind on server, and that our cloud ecosystem could be richer and more diverse if we could only lower the barrier to entry. And web application development is only becoming more complex. Customers everywhere continue to raise their expectations for user experience, performance, security, compliance, and data privacy from their SaaS providers. And since apps operate on the same customer data as the core product, protecting that data is a shared responsibility. This is forcing SaaS providers across the industry to step up their game when it comes to securing their ecosystems. So, we decided we needed a way to make it easier for developers to build apps in cloud, and we also needed to make it easier for customers to trust those apps that they were building. So we started exploring different ways that API providers can shoulder more of the complexity that comes along with app development. And we made the observation that Atlassian had been investing heavily in the trust posture of our own cloud products. So our first thought was, what if we could go well beyond APIs and just share our cloud infrastructure directly with our ecosystem? So we decided that a hosted ecosystem platform run by us was the way to go. But what sort of hosted platform? There are a range of options. Atlassian has a strong technology partnership with Amazon Web Services, so we first considered just hosting managed AWS accounts and allowing ecosystem partners to deploy into them. Then we considered a platform as a service model, or PaaS, as a slightly higher level of abstraction. Under this model, rather than deploying directly into AWS, partners would package a web application in a prescribed format, probably Docker containers, and then we'd run those containers for them in our cloud. And then finally, we evaluated a functions as a service platform, also known as a FaaS. This meant instead of whole web applications, developers would deploy a function or a bundle of functions which compose their app. Now, each of these options provided different levels of abstraction, with the PaaS and the FaaS options shifting more of the complexity burden onto us as the platform, but at the cost of some flexibility in how developers can architect their apps. Ultimately, we decided on a FaaS model, because this would allow us to shoulder more of the complexities of app development and provide the strongest platform guarantees to our customers. And we decided to call this new platform Atlassian Forge. In fact, what Forge is today is actually closer to an integration platform as a service, or a specialized app FaaS, because we go well beyond a typical FaaS like AWS Lambda or Google Cloud Functions by baking in abstractions that simplify app development for Atlassian products. We'll take a close look at some of these in a moment. But before we do, I want to point out that Atlassian isn't unique in this idea. Atlassian Forge is in part inspired by some other hosted app platforms like Google Apps Script and Salesforce's Apex platform, and other SaaS companies are launching similar offerings all the time. Like Forge, AppScript in particular has a strong focus when it comes to security and data privacy, which makes a lot of sense. If you're going to install apps from third parties into your Gmail account, you're going to want a platform that has some strong trust guarantees. Once we knew we wanted a FaaS, we identified two overarching platform goals. The first was that we wanted to make app development as simple as possible. We wanted a cloud platform that could be used not only by professional commercial app developers, but also by time-poor system administrators just looking to customize their Jira sites. We also wanted to have a strong customer story for Forge. We wanted to be able to extend the brand trust that Atlassian has to apps built by third parties running on our hosted platform. So our first step was abstracting away as much infrastructure and app operational concern as we could. With our old platform, building an app that could scale to thousands or tens of thousands of customers became a challenge in cloud architecture. A typical app would be composed of load balancers, microservices, queues, scalable worker pools, and various hosted database offerings, plus all of the usual observability, monitoring, and orchestration needed to keep services running on the public internet. We wanted a developer to be able to write a simple function in JavaScript, deploy it into our cloud, and then have that function work just as well for 10,000 customers as it would with one. And we chose AWS Lambda as the basis for Forge, and it works great. We can easily deploy functions that scale up as needed by customers and scale back to zero when they're not in demand, which makes Forge very cost-effective to run. We have a variety of function types that developers can deploy, and they can listen for product events like Jira issues being updated or created. They can run on a schedule, and we have a variety of other compute tasks that you can compose together to build apps. So this is great for a bunch of reasons. The first is that there's no infrastructure management. We run everything for our developers. The second is that ops is also simplified. We generate logs and metrics automatically and provide a developer console for devs to access them. The other great thing about abstracting away infrastructure is that it mitigates most web application security risks. These functions aren't sitting on the public internet, and they don't serve HTTP requests directly, so they're very difficult for an external attacker to attack. Plus, functions are ephemeral by design. Even if you could somehow breach one, they only survive for a brief period before they get nuked by AWS. So it means an attacker couldn't persist. Also, since we own the deployment pathway to Lambda, we can also monitor and scan client code much more effectively. Under a lot of SaaS ecosystems, the app tends to be a black box that sits behind a domain, and you have very little insight into implementation. Plus, with a FaaS, we can dramatically simplify onboarding. You can bootstrap an app in minutes by deploying a collection of functions from one of our pre-baked templates. Plus, and this isn't something that's quite shipped yet, we're also working on deploying Lambdas into every region that we have customers, and also making our attached storage APIs automatically respect the data residency requirements of the customers that install those apps, which will be an awesome customer story when that ships a little later this financial year. There are some fairly significant downsides, though, to a FaaS. The first is that serverless functions are a very opinionated way to architect software, and it can be very difficult to solve some business problems using them. For example, it's not going to be possible to run native AI models on Forge anytime soon. It's also challenging to retrofit serverless onto an existing web app, which means it is a difficult migration journey for some of our existing partners. It's also required heavy investment to build a hosted platform. Though Lambda does a lot of the heavy lifting under the hood, we've had to build a complex set of compute and storage primitives on top of Lambda, DynamoDB, and SQS that requires a high degree of R&D and operational discipline to run. One aspect that Lambda doesn't provide out of the box is network isolation. To have a really strong security and data privacy story, we wanted to ensure that Forge functions could interact with product APIs and Atlassian services, but wanted to strictly limit network requests to services on the public internet. To do this, we locked down the VPC that Forge functions are deployed into and created a data egress proxy that manages all outbound connections. Of course, cutting apps off from the internet entirely breaks all sorts of use cases, and so we allow Forge developers to declare an allow list of domain patterns that apps can connect to. This list is then displayed to customers when they install an app to give some more transparency around around how their data is handled. This approach allows us to tell a really strong data privacy story to our customers and also further mitigates security risks. Even if an app does somehow suffer from a supply chain attack, say by importing a dodgy NPM module, then by default, there's no way for data to actually escape from the platform. However, there is a downside. Developers have to maintain that allow list, which is a bit annoying, and the onus is on us to provide operational tooling like logging and analytics that partners would usually use a third party like Splunk or Google Analytics for. Alongside network isolation, we also invested in providing a strong tenancy isolation guarantee for the Forge platform. We wanted to ensure that app data couldn't accidentally leak from one customer site to another. So all Forge apps have an isolated invocation context and tenant-safe data stores that are tied to the current tenant. Now, this is great from a security perspective and also helps us to answer a fairly common request from enterprise customers who demand strong data isolation guarantees. The downside is it's fiendishly complicated to implement. By default, AWS reuses Lambdas across invocations. So we've had to design a special sandbox that sits on top of Lambda that's destroyed after each invocation. This has the drawback that state can't be maintained across invocations, which makes things like caching difficult, and also limits some legitimate use cases where you might actually want to share data across sites. Another problem that we wanted to solve was completely removing the burden of authentication and authorization from developers. Unfortunately, authentication historically has been very difficult to implement properly in our previous cloud platform, Atlassian Connect. This is partly because the platform has been around for almost a decade, and we keep layering on new features and security controls in response to possible threats. So today, Connect uses a symmetric secret for authenticating requests between Jira and apps, and we issue separate secrets for each customer site that your app is installed into. These secrets are issued via a webhook on installation that's also signed to prevent spoofing, so you have to verify it. This means even if your app would otherwise be stateless, you have to have a database just to manage secrets, and also have to be able to rotate those secrets on demand. That secret is then used to sign all outbound requests to Jira and inbound requests from Jira to you, using some pretty gnarly custom claims embedded in a JOT. And if you want to impersonate users when you make an API request, then you have to use a completely different auth flow that requires swapping your shared secret for a bearer token. So yeah, authentication under our old platform is complicated and hard to consistently get right, which makes it both a developer experience pain and a breeding ground for security bugs. Now, fortunately in Forge, we've always completely abstracted away authentication. Here is a Forge function that listens to issue events and posts a comment on any newly created issues. You'll notice here that we have helper methods for authenticating as the app's bot user or the context user who triggered the event. And you don't have to specify which Jira site you're making a request to. The function automatically infers it from the context. Now, note the conspicuous lack of secrets, headers, HMACs, OAuth, or anything else authentication related. We don't have to authenticate the webhook event or the outbound request to Jira. It's all handled by the platform. Now, incidentally, I ran out of time for a full demo, but this is actually a complete Forge app. If you deployed this along with its YAML manifest, it would just work and start creating comments in Jira. Now, I'm out of time, but there is a whole other set of aspects of Forge we could dive into. We have a declarative UI kit that enhances security and simplifies UX development. We have a new way of hosting secure iframes and a really neat set of developer tools that make it quick and easy to develop slick apps. But if you're an API practitioner, I bet you're wondering whether a hosted ecosystem platform is practical for your business. Now, I would say that going from REST APIs, iframes, and webhooks to a fully hosted cloud platform has been a huge learning journey for Atlassian. While there are a few similar players in the space, there isn't a lot of prior art to work from or off-the-shelf technology you can use. We've had to heavily invest in our ecosystem team, solve some really gnarly technical problems, and build a platform that meets our privacy and developer experience goals at the scale of Atlassian's business. We also have a pretty complicated migration journey ahead. While Forge is popular amongst new apps, we're having to work very closely with existing partners and are building bridging mechanisms to help them adopt components of the new platform. Retrofitting a FAS onto an existing app or other cloud infrastructure is not a simple task. But we are seeing some major successes, both in terms of customer demand for Forge apps, particularly from enterprises, and also some incredible developer success stories. Earlier this month, a brand new commercial partner wrote a great blog about how they went from having an idea but no Atlassian API experience to launching a Forge app on our marketplace in 2 months. If you're interested in reading that case study, you can find it at go.atlassian.com/onward. Or I would be thrilled if you gave Forge a try. It's completely free for anyone with an Atlassian account. If you don't have one, you can sign up and get free developer versions of our products at go.atlassian.com/forge. Thanks, that's the end of my presentation. Feel free to reach out on social media. I am Cannonboy, or I will be hanging out in the platform networking areas for the rest of today. Thank you, API Days Hong Kong. I'll now pass back to the MC.
Thanks, team. So we have a better idea about the iPaaS. So the next talk, we have Dr. Mathias, the API strategist at Software AG.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.